Hey there, and welcome. Have you ever really truly stopped to think about how you see the world? I mean, it feels pretty simple, right? You just open your eyes and boom, there it is, reality. Well, today we're going to pull back the curtain on what's really going on, because the greatest show on earth is happening inside your head, where your brain is the ultimate illusionist. So, let me just ask you this right out of the gate. Is what you're seeing right now actually real? The simple answer is, well, kinda. But the truth is way more complicated and, honestly, way more incredible than you probably think. Okay, take a look at this. This is called the Ponzo illusion. Now, those two yellow lines, they are exactly the same length. I swear, you could measure them. But your brain, because it's using those converging lines in the background as depth cues, absolutely insists that the top one is longer. This is the perfect example that you don't just see the world. Your brain is actively interpreting it every single second. And that brings us to our first big idea, the illusion of reality. We're going to dive into some of the invisible work your brain is doing around the clock to build a stable world for you, starting with one of its cleverest tricks. This trick is a superpower called perceptual constancy, and it's what stops your world from just being this chaotic, constantly shifting mess. Basically, your brain is committed to the idea that things should stay the same even when the information it's getting is changing like crazy. Think about a door opening. The actual image hitting your eyeballs changes from a rectangle to a trapezoid to just a thin vertical line. But you don't think, whoa, that door is warping space-time. Of course not. Your brain just knows it's a rectangle and that's what you perceive. That's shape constancy doing its job. And it's the exact same thing with size. You see a car way down the road, and as it gets closer, the image it projects on your retina gets bigger and bigger. But you don't panic and run away from a giant, growing monster car. Your brain just applies size constancy and understands, nope, the car's not growing, it's just getting closer. So your brain is constantly making these adjustments, right? But maybe its biggest magic trick is turning the flat, two-dimensional images from your eyes into the rich, three-dimensional world you live in. So how on earth does it pull that off? Well, it basically acts like a detective, and it uses a whole bunch of clues. And get this, a lot of them work even with just one eye open. Things like interposition. If one object is blocking another, it's got to be closer. Or linear perspective, how parallel lines on a road seem to touch in the distance. And of course, relative size. Smaller things just seem farther away. Your brain pieces all these clues together in an instant to create the illusion of depth. So that brings up the big question of how. How does it do all this? Turns out, your brain has two main strategies that work together. One is like carefully building something from scratch, and the other is more like making a really, really good guess. These two strategies are called bottom-up and top-down processing. Bottom-up starts with your senses. It's totally data-driven. Think of it like building with Legos, piece by piece. Top-down, on the other hand, starts in the brain. It's driven by your knowledge and experience, more like that detective we were talking about, using clues to solve a case. Let's break that down. With bottom-up processing, your brain is like a construction worker on a job site. It's just taking the raw materials, the lines, the colors, the shapes hitting your eyes, and it's carefully assembling them, bit by bit, into a coherent picture. It's building perception based only on the evidence coming in. But you can imagine, that's kind of slow. So to speed things up, your brain also uses top-down processing. And here, it acts more like that veteran detective who's seen it all before. It uses context, your memories, and what you expect to see to make a super fast, educated guess, filling in the blanks as it goes. And here is a perfect everyday example. You can read that, right? Stop sign. You didn't even have to think about it. Your brain didn't need all the letters because it used the context, your past experience of seeing stop signs, and it just filled in the gaps instantly. That right there is the power and speed of top-down processing. And here is the absolute crucial point. It's not one or the other. Every single moment of your waking life, your perception is the seamless, beautiful blend of both strategies. It's a constant conversation between the raw data coming in from the world and the massive library of knowledge you've already got stored in your head. Okay, but what happens when this unbelievably complex system glitches? By looking at the rare cases where perception actually breaks down, we can get an even deeper appreciation for just how brilliantly it works the rest of the time. So let's look at a condition called visual agnosia. Now, people with this aren't blind, not at all. Their eyes work perfectly. They can see all the lines, all the shapes, all the colors of an object, but the connection is broken. They just can't recognize what the object is. Seeing is there, but understanding is not. This old case note really brings it home. A patient saw a pair of glasses and described it as two circles and a crossbar. The bottom-up processing was working perfectly. He saw the component parts, but his brain couldn't put that information together to recognize a familiar object. The top-down recognition just wasn't there. There's an even more specific version of this called prosopagnosia, which you might know as face blindness. People with this can see eyes, a nose, a mouth, but they can't assemble those features into a recognizable face. Not their friends, not their family. Some can't even recognize their own face in the mirror. It just goes to show you how specialized our brains really are. Color is another amazing example of this. You know, what you experience as red is just your brain's unique interpretation of a certain wavelength of light. It's not inherent to the object itself. And for a lot of people, the biological machinery for making that interpretation has a little genetic glitch. So for example, with protanopia, problems with the cells that detect red light can make reds look more like a dark beige. With deuteranopia, which is pretty common, reds and greens can look really similar. It's not that they're seeing a wrong reality, it's just a different constructed reality. So, if you take one thing away from all of this, let it be this. Your reality isn't a photograph. It's not a direct, perfect copy of the outside world. It's more like a painting, an active, brilliant, and totally subjective masterpiece created for you, fresh and every single moment, by that incredible artist inside your skull. And that, of course, leaves us with one final, pretty mind-bending question to think about. If your entire reality is constructed by your brain, if it's based on shortcuts and expectations and biological limits, what are you not seeing? Thanks for watching.